to think about how we're going to translate three-dimensional space to two-dimensional paper, right? Two-dimensional paper, in our case, traditional art, realism and all, means that it's like a window into a three-dimensional space. Here, sit down on it. So, think of it as a window into a world that you are creating or recreating, right? So in that world, everything has to make sense. In terms of traditional fine arts, everything is making sense in proportion, linear perspective, color values. It's all supposed to be kind of closely representing reality, right? What we see in nature, for example. If we're creating an artwork that doesn't closely represent reality, but we still want it to look good and right and like with some kind of sense in it, even if you don't follow the rules of linear perspective or you are using them in a different, clever way, they still have to make some kind of sense, right? What we don't want is an artwork where the things and shapes you're drawing, objects you're drawing, are chaotic, out of control. So that's why you want to learn the rules of linear perspective, because it will help you understand how to do three-dimensional objects on two-dimensional surface. Once you grasp the understanding of linear perspective, and every time you draw something you never miss it, it always looks in the right perspective, then you focus on the next step, the right proportions, then the color value, then you learn how to draw something in a naturalistic way. Then you start to understand how to use these rules to your advantage to create an artwork that doesn't follow all those rules in specifically that way, not totally representational, but actually tells another story. But not in a chaotic way, right? You don't want chaos. You want, even if it's not totally traditional, it still makes sense, and those who can see will see that sense in it, and it will be actually intellectually stimulating to understand and read those artworks. In iconography, they use what sometimes is called reverse perspective. But it's not because the iconographers long time ago did not know how to do perspective. It's because to them the traditional linear perspective was not important, and the way they portrayed it, there were other meanings behind it. Okay, so I won't go into iconography yet, but first thing first, if you're sitting while drawing and you're standing while drawing, your eye level is going to be different, right? So the same cube drawn will be looking differently. Yours will look different from hers. So I am standing right now, and if I come close to this cube, I can see that my eye level is somewhere right in here, right? So that means my perspective line that I would be drawing on my paper is rather high. You can make a note, just basically, let's say, if you feel like you come here and your eye lines up with this, or just above this, always keep an eye on that as your eye level. For her, when she's sitting, her eye level might be rather like even going right through the middle, you see? It might be a little higher here, it might be a little lower, but it doesn't matter. We can even just like put a little mark in here, so you would continually be reminded of where that eye level is. At home, you can draw objects like a regular square box, like a tissue box or something that's close to a square box, maybe a gift box you have somewhere or something. And you can draw this for practice, and you can draw it at different eye levels and practice that. But the main thing is, like, for now, I'm looking at that, my eye level is way high, so what I'm going to do is I'm going to put it like right up here, right near the edge of my paper, right? This will be like lightly indicated eye level. And obviously it has to be parallel to the edges. You already drew plenty of straight lines, so it shouldn't be a problem. It doesn't have to be super dark either. All right, Sophia? You sure, Sophia? You sure you don't make this line too dark? Okay, it just needs to be lightly there. All right, So then we are going to be placing a cube somewhere down here because I have a lot of room before the eye level, right? Remember how we did the stylized flower and you were figuring out proportions and placements? Those rules of measuring come in right now. So right now I'm going to measure the height of my cube, the closest to us edge of it, corner, and I'm going to see how many times that distance fits before my eye level. Looks like it's 2 times. Looks like I have 2 cubes and then my cube. See? So I'm going to go ahead and indicate that my cube will end somewhere along this line. Again, it's a more or less straight line, parallel to the edges. Oops, lightly indicate that. Doesn't have to be super long, it just needs to be here somewhere, okay? So it can be as simple as just like a short line here, no big deal. So then you are sizing up your proportions. It's almost like you already have this height, right? And now you will just need to choose the width. So you can now divide this in about 3 equal sections. And I'm just throwing this in approximately. Now I'm gonna see, is this close enough? Kind of close, right? Let's perfect it a bit more. Let's say that this is one distance. You can measure it. First, always throw it in as your first intuitive guess, your lines, and then perfect them, right? It's like super close. I just need to raise this teensy-weensy a little bit. So it's not as high as it was first, no, not as low as I put it in second, and that goes just a teeny bit higher. All right, so even though I'm doing the very general first steps, I'm already trying to be a bit more precise. Okay, looks like I've gone too far, still need to go far, a bit higher. No, lower. Okay, let's go back here and measure that more precisely. All right, 1, 2, 3, that's close, all right, so my whole cube has to fit in here. Why do we do it this way? Because we're studying linear perspective, and this eye level is extremely important to us at this point. It's extremely important to learn how to orient yourself in 3-dimensional space, how all the objects you're seeing are related to you. All right. Once you practice that relationship, you will be able to see it and just feel it, sense it. You won't have to struggle figuring things out anymore. All right. So in this whole window, it's becoming 3-dimensional space because my cube is going to be fitting in this little bit of a space. On your bigger papers, obviously it's going to be bigger, but I have this size of a sketchbook. So the next step is to position our cube in such a way that we have enough room to bring one side to a vanishing point in here. So for example, that cube over there sitting, it's definitely one side is turned a little bit stronger than the other, right? One side has just a barely turning and going away from us, the other goes away a lot stronger and faster. So they all fit in the eye level being so high. That means they have a long way to travel. So what you can do is size it up like this first. So let's say our vanishing point to where all these lines are going to come to is going to be something like this. It has to be completely straight, right? It cannot be bending or anything. Completely straight. I'm sizing it up because I'm running out of space here. So I'm kind of compromising between exactly what I'm seeing and this. So this is the direction at which the table on which the box is sitting, this rectangular structure, cube. This is the angle at which it's going away in this direction, right? It's going away from us as a general plane. Any rectangular object sitting on this table, if it's parallel to the box, will share the vanishing point. If it's not parallel, it will have another vanishing point for itself, but the angle will be matching. All right, so I got this intersection. It's a good, helpful intersection. I can now bring this line up, and this becomes the side of the cube, right? The side of the cube is not going to intersect here. This is where the top of the cube is already ending, right? So this whole side of the cube should be more like this, not even lower, like this, then like this, then like this, and like this. I'm just telling you how to imagine it ahead of time so you don't mistake that for the intersection. The whole cube has to fit in here, right? All right, but nonetheless, we can now say, all right, so here it is kind of close to what I'm drawing anyways. I'm seeing that. So I can now measure the width of the cube that's going to the right and away from us compared to the width of the cube going to the left and away. And what I measured approximately looks like this size. That is because I guessed the size first. Let's see if it will work. This size fits into here once, twice, and kind of like another half, kind of like this. If I draw it here, will it look like my box?
It's a little more rectangular.
Right. So that means we are pushing this, right? We're making it wider. Okay. I'm pushing that. I'm making it a bit wider. So if this is, let's see if this will work. 1, 2 and a half, somewhere in here. How is this now looking compared to our proportions? Kind of starting to look
better.
Yeah, better.
But I think it's just a tiny bit.
Remember that this will also change to this angle, right? All right. So, by the way, you can also just stand here, take a measurement of the angle at which that side is going away and compare it. You see, if I did it exactly how I saw it, it won't fit on my paper. I'm just doing a demo, so I have to fit it into my paper. And I don't want to push my box too far this way because I'll be explaining how to go in this direction when you don't have a vanishing point. So it's going to be another set of rules, right? So just as long as you understand why I'm doing it this way. It still is going to be geometrically correct. That's all that matters. So my angle is closer. Essentially, I'm saying that the box is turned a little bit stronger than what's sitting in there. And I can do it as well. But it really, for my sake, it doesn't matter. For you, I can turn it exactly. So now, if I'm assuming that this is doing something like this, and this side of the box will be shaping up, looking kind of like this. Let's just make sure that this and this works fine, right? Because remember, if this is the height of the box, this will also have to be traveling toward the vanishing point in a very straight line, right? So if this is too high of an intersection, the box will be beyond this, right? We don't want that. We are trying to get proportions right. And I'm looking at it right now, comparing it to there, and there I'm seeing like, yeah, this is starting to be a bit wider open. So what I'm going to do is I'm going to size everything slightly down, because this will probably have to come down a bit as well. So if I go back and kind of in between of what I've done, just like that, and I will lower this just a bit, and still head for my vanishing point over there. I need it more straight. One here somewhere. No bending lines. Right? So I lowered that. That means this is starting to look wider, right?
Mm-hmm.
So that means if this is our approximate line, perhaps we can now do it 1, 2, and a half. We're kind of like back to this. Remember that this one is also going in this direction, right? So it's starting to be closer, but still feels a bit narrower, right? So the other thing you can do is measure the side width. You can measure the length of the side and compare it to the length of the other. You can measure how tall the whole cube is compared to how long it is going in the other direction, right? So this is basically your true size, and going in the other direction's got to be short, because it's now at slight angle going away in the three-dimensional space, and so we still have room. So to make it more like a cube that is going away in the three-dimensional space, I'm adjusting it, measuring, intuitively adjusting things, and there. So this does not have to equal, it doesn't have to look like a full square, it does have to look a little bit narrower. And so now we can you can go ahead and get the angle of the other side, compare it to here, and get it down. You see how the initially that straight line that I drew is so helpful, right? Because you're comparing the whole thing of all these angles to this straight line. So as long as you have this straight line, the others start to become more easily visible, and you start getting the idea of which lines are good. It's all in comparison. Alright, so we will say, okay, this seems to be working out. This is definitely just needs to be very, very straight. No wobbliness. This needs to be very straight. Now we've constructed almost everything in here, in the front. We now need to bring this line more and away from us to the left into that space. So again, try your best to do these lines nice and straight, so they're not wobbly, they're not sinking, sliding, bending, right? As long as they don't have to be super thin at all, you can have them like this, nice and fuzzy, but as long as overall they're going straight, right? And don't forget to step back and double check straight or sagging or what. All right, yeah. So it's shaping up. We have this side that seems to be like it's a pretty good construction right now. See how the angle changed. Steeper, less steep, right? That is your perspective, that is your Fushigi. Here I have my best guess. It's same thing. If we have this mild angle here, this angle will also be slightly milder than this one, right? Where it's going to be the least mild, the closer it gets to the horizon line. If this box was being raised, if I put it on a bunch of other boxes, raised it up, it's going to get right to the horizon line, and both of these lines will completely line up with it, right? You've already observed that. Right now we have this angle, and we need to duplicate it here and drop it just a teeny bit, right? For that perspective. While here the angles change dramatically as it gets closer to the eye level. Here they don't change so dramatically. But we can't change them too fast either, right? So how are we gonna know, how are you going to know if you got it right? If your angle is changing too fast or not fast enough? You are going to first basically compare it to this line here. Compare it and see, is it exactly parallel? If it's exactly parallel, you can literally just take your pencil, line it up and bring it here. If it's exactly parallel, it's close, it's good enough. It's close to and good enough to get started, but then you know to drop it a bit, right? So I'm comparing this right now. I'm bringing it up here and I'm seeing that there is that little wedge. That means that I'm already dropping it slightly, right? So I'm happy with it, but I also have experience. You don't have as much experience at that. If you don't have it, if you don't have that drop, if you did it more parallel, it's fine. You just need to know to add that little drop, right? Also extend it further into space. We extend the lines into space. Why? What do you think?
To make sure it's parallel, so they don't connect.
Right. Because you can see easily, more easily, the longer the lines are, where they're going. Are they changing direction? Are they parallel? Are they gonna crisscross sooner?
Yeah.
Right. We don't want these lines to crisscross like just outside here. They can only crisscross here.
Yeah.
On this line. So however long, if I need to project it another 3 feet into space, this is where they're going to intersect, but they're going to intersect on this side. All right, so here's the trick. Hack, right, Sophia? You call it hack. Here it's easy because we connected to the vanishing point. Not so easy here, the vanishing point is too far away. But what we can do is, first, we can just double check this size compared to this size, already shorter, right, at this intersection. And it's already a bunch shorter on the other side, right, at this intersection, which is a good sign. That's a good sign. So what are we going to do now? We are going to see by how much shorter and make it a little bit easier. And we could compare, like, for example, this size to this size, or we could compare this one to this one, but you see it's just like a tiny little bit, right? You could also, and I'll just put a dot in here so you see the more true intersection. You could also compare this size to this whole thing as well. You could also compare this size to this, or this size to this one. You see, it's like there are various ways which one you can compare to, but the main thing we would like to learn at this point is that all of these lines, and even the one that's going to come out of here and head in this direction, and eventually from another corner and from the corner down below, they all will be getting closer together at the same rate. Mathematically, it's the same rate, same proportion. Proportionally, they're getting together in the same way. So let's do this right now. We are going to measure this here, and we're going to see how many times it fits in here. 1, 2, 3, oh, almost 4. Almost full 4, maybe just a little tip over, right? That means if we take, if I got these angles correctly, and I measure exactly vertically right here, which means it's what this box would be if I kept pushing it in this direction. This side would fit proportionally into this space 4 times in a little tip. Okay, so I'm taking it here. I'm doing 1, I'm doing 2, 3, 4, and a little tip. But this tip seems to be a bit bigger, right? So that means I need to make sure that this here stays right here, and this one becomes just a tad on the higher side. This is the right proportion, okay? So that line into space goes just a little bit higher. So that tip that gets shaved off there by the eye level doesn't become too big, because I'm maintaining my proportions, right? So here it comes through right here, right to this intersection, right to here, right to here. You can always put those points in. It's very good to put your points, connect the intersections nicely and evenly, right? So right here, right here. The proportions are maintained. From now on, everything you draw in this direction where the vanishing point doesn't fit works exactly the same way. You don't always have to compare it to all the way to the horizon line. Once we have this and you got them exactly right, you're happy with it, you know it's the right proportion. When we're doing these two lines, you compare this distance to this distance. And as long as it's the same rate of getting closer together, it's totally fine. So let's put in this one, just the first guess. First guess, let's put the first guess like, oops, I went too high. Like this. So at this point, a lot of people who are just learning, a lot of students, tend to drop it a little too close, too eager to get that perspective right. But it's not a problem. It's better than nothing. If it's a little stronger than we need to, it's totally fine. We are simply going to now take this, or even this one, doesn't matter which one, okay? And we're gonna now measure this distance, compare it to the bigger one. It's like 2 and a little bit, right? That means if we measure it here, like this is, if we divide it in exactly 2 halves, right? And let's push the halves a little bit apart, that will be that little bit. Let's see, if this is half, good. And this is that little bit, right? Do you see what I'm saying? Yeah. All right, good. So if we take now this distance, we project it here, this is where it should be. See? So it went down too fast. And so now we simply adjust. So go ahead, connect this point to this one. Okay, let's just throw it in however we can. And I erased my previous line for where the cube is supposed to stop, right? So don't worry about that. We are pretty much hitting, the cube is fitting within that space, right? All right, so here we go. Now that we put in a whole bunch of lines, we can now perfect it, narrow it down. And so basically what it means is that by the time this gets to the cube area we are drawing, our line, our back side of the cube is going to be this. This is its direction. This is its angle. And you see how tricky it is because this angle is so mild, right? All right, see how it now looks like pretty plausible, right? Okay, so the next two things, we got this angle, but we also have this corner that we can easily connect to here. See how if I project this line in here, it comes close to this corner? That's a helpful thing. So that means if I kind of start and compare my new line to this one, that they can go almost parallel, but start getting closer and closer together. And somewhere in here, they like completely blend. right? I see that this one I can kind of punch up a bit. Okay, so looks pretty plausible. A little bit dipping in here. All right, let me fix it up so it's not so dippy. Okay, now more or less straight. Okay, so that means that we've connected the back side that we're seeing through the cube, and we also have this intersection, same thing. If we connect it through to the vanishing point, just again make sure it's very straight. Okay, it's bending a bit here. Let's bring it down a bit. No arching. More or less straight. But again, so you see, like I'm doing it very lightly, and I'm not even stressing over like, is it going to be super straight or not? Just put a bunch of lines in. Out of those lines, the one you need will become visible, and that's all it is. All right, so it looks like my back of the cube is appearing and it's intersecting right here. That's exactly right. That's getting the angle of this, and this gives you the exact intersection for the back corner on the top, right? So now the next step, see here, it's we can start projecting it in this direction and get this corner, but the easier thing, because here is that very gentle angle of incline, but let's make it easier for ourselves because this is easy. Now we have this. Now we can just project it exactly straight down, completely vertical. As long as all of these lines, sides of the cube are parallel, you can't miss. Looks like this is what is happening, right? So we can now connect this corner to here, right? We can also project it through, and we can double check our angle of incline. Is it the one we need? Is it lower? Is it higher? What is it? Something like that. So we can do the same thing we did before, but technically it looks like it's already working out. But just for the sake of the argument, right? Just for the sake of knowing, we can say, all right, this distance here fits into this distance here, 1, and maybe like 2/3. Yeah. All right, so that means that this distance here has to fit into this distance to the top, right? 1 and 2/3. Okay, we're taking this, if this line is correct. Here's 1, oops, and it's kind of working out. Looking like 2/3, right? Yeah. Because it's like now it's this distance to here. All right, so at this point this is slightly less important, but because we're training the eye, it's less important because this bottom already is turning out well. But because you're training your eye to see all of this, to see all that straightness, right? It's good to still practice doing that. All right, so here's your cube according to linear perspective. Now you need to just clean up your sides, make them all nice and straight. So now is where you can stress over perfection to the degree that you seek it. And the very last thing is, because it's a structural drawing, you want to still make it feel three-dimensional. And you make it feel three-dimensional by making those parts of the structure that are closest to us the darkest and the thickest. Okay, so I will darken that and thicken it. It's the closest to us edge. The other edge is closer to us right here, so I will darken and make it thicker. But as it goes away, I will make it slightly lighter and slightly thinner. and that three-dimensional feel should start appearing. Obviously that all the lines that are in the very back of this cube, they are going to be feeling more like we're looking through the box, so they need to look more like ghostly. But the most ghostly are your perspective lines. Those are the most ghostly. Okay. I keep making it a bit too thick. See, I'm seeking perfection. Yeah, that means you shave off a fraction of the hair width. Okay, so this is more like it. More like it. So make it as straight as possible, as dark as possible. I'm starting to run out of what my pencil can do. You have darker pencils, so that's good. Same thing with this one here, right? It's going to be, because it's going away from us rather gently, it's not going to get as thin as that. Mm-hmm. But it will definitely be the thickest on this corner. So it's kind of like a degree of thickness and similar darkest at this corner. Like this, darkest, thickest at this corner. And slightly lighter, but still rather thick here on this corner. Okay. Clean this up more. Okay. I will finagle with this afterwards. I'm just rushing to get started. You get the idea now, right?
Yeah.
This becomes slightly lighter than this and slightly thinner. And I can finish it while you're already drawing, so you can then just come over and look and see what it's supposed to end up with. Same thing, this will be slightly darker, but not as dark as this, and getting thinner toward here. This will be slightly stronger than this. This will be pretty much the same as that. This will be similar to that, pretty much the same. This will be equivalent of being lighter and thinner, equivalent of this one. You can, if you want to make it slightly lighter, great. This one on the inside will always stay the lightest of all, right? Because this is where all of these ones are coming together. So as this becomes lighter and thinner, this becomes lighter and thinner, this becomes the lightest and thinnest of all of them. And these guys, clean them up to where they start looking like very thin, ghostly lines that you're still seeing now. They're still helping you see that perspective. Your eye is still sensing it, but they are nice and light, ghostly. Because you are learning to see reality that is there, but not visible to untrained eye. Like that. So anyways, I will stop here so you can get started.